Welcome to this practical demonstration on estimation of sodium in soil. Exchangeable sodium is an important chemical parameter in soil. High sodium levels disrupt soil structure and reduce plant growth and crop yield. Hence, analysis of exchangeable sodium is important as it helps in identifying sodic soils and planning proper management. The analysis includes four basic procedures. The first one is preparation of standard, and the second one is preparation of sample. The third one is measurement of standard emission. That means aspirating standard solutions into the flame photometer and calibration of flame photometer. And the fourth and the final procedure is sample analysis and calculation. Now we will move to the procedure of standard preparation.
Sodium chloride is the analytical reagent used in this experiment. Weight 2.54 gram of sodium chloride to make 1000 ppm of stock solution. Now dissolve the 2.54 gram of sodium chloride in a volumetric flask containing 1000 ml of distilled water. Shake well so that the reagent get dissolved. Thus, the stock solution of 1000 ppm sodium is ready. Take 100 ml of the 1000 ppm sodium solution in a 1000 ml volumetric flask and make up the volume to 1 liter using distilled water. This gives 100 ppm of sodium stock solution. Measure 20 ml from 100 ppm sodium solution. Make up the volume to 100 ml using distilled water. This gives 20 ppm standard solution. Similarly, prepare 40, 60, 80 ppm of standard solution.
Now we will move for the sample preparation for the analysis. Pour 10 ml of soil extract obtained from the CEC experiment into the vial. This is a sample for analysis during the experiment. Now the sample and standard is ready. Now we'll go for calibration of flame photometer and sample analysis. Now switch on the flame photometer and now switch on the compressor. The pressure should be between 0.3 to 0.6. Now switch on the device and wait for a few seconds. Now turn on the gas cylinder. Now I am carefully igniting the flame using a matchstick to start the analysis procedure. Now the flame photometer is ready for analysis. Now click on setup and enter the number between 1 to 40. Now it's showing higher concentration because you are going to analyze soil sample. Now click on the edit option and choose the element to be analyzed. Press 1 for sodium and press the enter button. Now they are asking for the number of standards to be analyzed. We are analyzing 5 standards. Then enter the concentration of each standard like 20, 40, 60, 80 and 100. Now press enter for the dilution factor and press on 3 for running, and now aspirate distilled water. Distilled water is taken in a beaker and aspirated into the flame photometer. Now press the enter button and wait for a few seconds. Now aspirate the reference solution. Reference solution is nothing but a solution of non-concentration. Let's aspirate a non-concentration, that is 10 ppm solution into the flame photometer and wait for a few seconds. Now aspirate distilled water and press the enter button. Now we want to aspirate each standard one by one. First we aspirate 20 ppm standard followed by aspiration of distilled water. Then we aspirate 40 ppm standard followed by aspirating of distilled water. Then we aspirate 60 ppm standard. Standard is aspirated in the flame photometer followed by aspiration of 80 ppm standard and press the enter button. Then we aspirate distilled water and press the enter button, followed by the aspiration of 100 ppm standard and wait for this few seconds for the calibration to over. Now we will move for the analysis of sample. Now we will press the enter button and we place the sample into the tube for its aspiration into the flame photometer and press the enter button. Now it shows the reading as 94.54 ppm. Now we are moving into the calculation part to calculate the amount of sodium present in the given sample. So in this slide, we are calculating the exchangeable sodium content of the soil. Here the flame photometer reading gives us the sodium concentration as 94.54 ppm. Since ppm is in milligrams per liter, we convert it into milliequivalent per liter by dividing by the atomic weight of sodium, which is 23. So we get 4.11 milliequivalent per liter. Next we substitute the values into the formula. Therefore the final result show that the exchangeable sodium content of the soil is 41.1 milliequivalent per 100 gram of soil. Now, as per the calculated result, we arrive in the following inference. Our soil sample is having high sodium content. So, the soil is sodic in nature. So, poor soil structure, low permeability, and having reduced crop yield. So, for management, we go for gypsum application and leaching.